So 2, 6 are related to the horizontal asymptote. So what happens when you let x get really big? Positive or really big negative? Okay? So they're completely related to the stuff you already did in pre-calculus. Hopefully, if you remember it. It's 8 years ago. Okay. Review it. Now we're getting into where you guys want me to get to if you've had calculus 4 is starting to get towards actual derivatives. These are not the derivatives from like financial stuff. Thank God. I'm a business worship. Remind me, what is the formula for slope from algebra? Right? So the really funny thing is we start calculus stuff from that. Remember the whole thing about if I want to find the slope at a point, I try to get 2 points, because that's the only way to find a slope is 2 points, but then I let this point get so stupid close to that point, they're basically the same point. So if I have a function and I want to know the slope right there, I want a slope right there, I go a little bit away from that. Let's go this way, just because. X plus h. So there, this will be f of x. This would be f of x plus h. And of course, what we did earlier in chapter 2 is we made a table of values, and we actually physically let that point get closer. If I'm going to 2, it'd be 2.1, 2.01, 2.001. And then we try to see the pattern. Now we're going to develop something that I don't have to rely on looking at the pattern, right? I can actually get it perfectly right. And then we're eventually going to make it into a shortcut. But we're not there yet. So what would the slope be between these 2 points? F of x plus h, I like it. So that y minus the other y divided by
over x plus h minus x.
So of course you get h on the bottom. I like it. Now what is it we did that I just said a couple times? We let h, how do I restate what I just said? We let those points get closer, which means we let h get small. How do I capture that with a limit? And the limit that h goes to 0. Right? And that's basically what we're doing, creating those table of values, letting the value get really close to whatever. So we're letting that separation between the two go to 0. So is there ever actually just one point I'm looking at? No. But it's the limit, so it gets as close as you possibly can. So that is what we call the derivative. The derivative is the more general term for slope. So when we say slope, we very often think lines, straight lines. So the derivative is the slope at any point for any function. It itself will be a function if my slope is changing. So the symbol we use for that is f prime. We also use other symbols. That's the one we primarily use. There's a number symbol that looks like this. So this is, if you think about it, this one was really controversial when it first came out. How do I get the slope at this point? Well, I say a small change in x and a small change in y, and I take that ratio. So this would be the change in y divided by the change in x. So did any of your teachers ever do this for slope? You guys remember what that delta meant, that little triangle? Change in. So basically, this is a big step. When you do a secant line, that's a delta. That's a big step. This is an infinitesimally small step. So these are what's called infinitesimals. It sounds like a group of very small superheroes, but what it always sound like to me. Right? So you can either have the prime notation or you can have the d by dx notation. The reason why this is really, really good sometimes is you might have a different variable, and this kind of tells you which variable you're taking the derivative with respect to. So especially if anybody has to go to Calc 3, which is multivariable calculus, I want them to tell me which frickin' variable am I looking at right now. If there's a bunch of variables in my equation, I want to kind of look at one. Tell me which one. Right? So this notation is good in that respect. So let's do a couple examples. Let's do one that we know already. So if my function is this, my function is 3x minus 2, what is the slope of that? It's frickin' 3. Right? But if I have to use the definition of derivative, so if they ever say in the homework, or if I say on the test, use the definition of derivative to find, then you must do this. So here's the definition of derivative to find the slope of this. So I have to investigate this sucker here. What is f of x plus h? What am I doing with x plus h? I have a special place in my heart for the people that do this. What? No, you take x plus h, you shove a sucker in there. Right? 3 times x plus h minus 2, which is 3x plus 3h. So then now you built that, now throw it in. So the limit as h goes to 0 of 3x plus 3h minus 2. The next place where people make a mistake, so that's just f of x plus h, cool? Minus, now what have I done wrong? I've done something wrong. Yes, good. I'm not supposed to subtract a part of f of x. I'm supposed to subtract f of freaking x. So I have people do that, and they're like, it's not working out the way it did in class. You picked all the easy ones. No, just do it right, and it'll work. That's over h. So what happens here? 3x is canceled, right? Minus 3. Negative 2 plus 2, those cancel, right? So you get 3h over h, which is 3. I don't care what the hell h is, it cancels. Remember, that's the whole idea with limits. If I just start doing algebra stuff, the problem should cancel. When I try to throw an h equal to 0 in here, what am I going to get? 0 over 0. Do you guys see that? If I let h be 0, it's indeterminate. I killed the problem, I can get the answer. And of course, does that jive with what we know the slope is supposed to be? Of course. So let me let you try a slightly more difficult problem. And let's reason this out before we do this. And I know that some of you guys know the answer to this. I don't care. Don't say it. Shut up. So if I have a problem, or a bold, what's true about the slope back here? Like at -1, what's true about that slope? What can you tell me about that slope? It's definitely negative. The slope decreasing would be a second derivative. What does slope tell you? It tells you how the function is changing. So if you start talking about how the slope is changing, do you see how that's another level? It's like saying the economy is still decreasing but at a slower rate. Oh, that's a second derivative. Holy shit. Yes?
Oh, wait, never. I got it.
Sweet. I love it. Makes my job easy. What's the slope right at 0? 0. Because right here is negative, and then it becomes positive, so in the middle it must be 0. So we already know what's supposed to happen. So whatever the function I get from the derivative better agree with what we just said. When I plug a -1 in, it better be negative. When I plug a 0, it better be 0. When I plug a 1, it better be positive. So do it. Figure out. Use this to figure out what the slope is at 0. So first figure out what f prime is. And then plug a 0 in. too bad, right? Obviously, if it was cubes or fourth powers or 11th powers, x plus h would be the 11th power. Can we FOIL that shit out? Not really. So we'll develop a shortcut for this, depending depending what the power is, we'll be able to predict what the answer is going to be. So up here, what do you get? X squared plus 2xh. The x squares go away. Everything that's left has an h in it. That will always happen for most of the... I love the way it's so silly. They'll almost always happen for the functions we look at. Almost always. So then, and what happens, so the h's now do what? They cancel. So that h cancels, and I lose one h there. Right? And what's the limit as h goes to 0 of 2x plus h? 2x. Does that jive? So what's the derivative? So we just figured out that's the derivative function. So that will tell me the slope at any point. So if I want to know the slope at -1, what is it? -2, just like we thought it should be. Slope at 0 is obviously going to be 0. The slope at 1 is going to be 2. Nice and symmetric the way it should be. Oh, this is really, if you let it be, this is so flippin' cool. I mean, lines are, slope here, and then I know it everywhere. This is just so, like, I don't care what kind of curve it's got. Every function we're going to be able to attack and then know what the slope is at any point on that function. That is kind of cool. And what do we use to do it? The same thing we did in algebra. y2 minus y1 over x2 minus x1. We just couple it with this idea, which of course explains why we spend so much time figuring out what the limits are and how they work. So when we got here, that wasn't a big deal. Maybe. Let me do, I'll do one that's a little weird, and then we'll head out. I'll let us out here a little early. Since you're all probably were brain fried after the quiz anyway. See how much sinks in today. Here is one that is definitely, oops, again. This one's, all right, I love that reaction. This one is fun. This is the correct reaction. So I want to figure out what f prime of x is using the limit definition. So for anybody that knows what the derivative sign is, I don't care. Don't give the first shit. At least you know what the answer should come out to be, right? But that's not as good as knowing how to do this. You just know a shortcut. What do you do? So what do I get here? What's f of x plus h? Now, you see the immediate problem. This is not a polynomial function or like a logarithm with logarithm rules and stuff. There ain't shit I could do to the top directly, really, but there is something I can do with this. So there is when I teach trigonometry, I like to make students realize that cosine is an asshole. Cosine is an asshole. You're all like, they're all flipping assholes. But no. Cosine is like next level asshole. So, what do I mean by that? I don't know if you guys remember what this identity is. Anybody remember this identity? See how sine is nice? It's like, I got a plus sign, I won't touch that plus sign. Why don't we take turns, cosine? Just to remind you, cosine of a plus b, cosine says, I'll be first, screw you, sine. You got a plus, who gives a shit? Now you get a turn, sine. Doesn't that help you remember? Now I do, when I teach trigonometry, I show the proof for this. But once we've gone through the proof, which is a little painful, I tell them my whole theory about cosine being an asshole. And actually it goes everywhere. Some of you guys that know derivatives, isn't the derivative cosine negative? Oh, such an asshole. Right? So it actually goes further. That's the first place I started to put that theory together. And now my colleagues keep telling me, did you think about this? It's an asshole here too. I'm like, holy shit, it's an asshole every freaking week. All right, but it's here. This is the nice guy. Right? This is the pushover here. He's like, oh. So how could I rewrite this then, using that rule up there? Sine x, cosine h, got it. Plus sine h, cosine x, minus sine x, all over h. Now what does cosine do when its inputs go towards 0? Cosine goes to, what is cosine of 0? 1. It's continuous. So I can just put a 0 in. So it goes to 1. So I just see, and what happens to sine x? Cancels. Then I kick ass. So then I get the limit as h goes to 0 of sine h cosine x over h. Why can you not cancel the h's? Because this does not mean sine times h, right? Right, please, don't kill those, because then you have sin. I mean, it's like, without anything in it, it doesn't mean shit. Yes?
I get how if you put the 0 for h, it cancels the cosine, but if you're not like substituting anything for the x, how can you cancel out the sines?
Oh, because sine x minus sine x is 0. I don't care what x is. Yeah. I like it though. I understand how the more you got to worry about, the easier it is to not realize it's that simple. Don't worry. Everybody's like, yeah, I got you. Now here, this really depends on, see how that doesn't care what the hell h is? So it really depends on what this limit is. Right? And if we investigate that, let's investigate that. Remember, this is the last thing we're doing, so freak out. Let's just look at that by itself. This is really kind of a nifty result. If I just look at this by itself, put the result in there. So let's do like we do when we investigate stuff we don't know. We make a little table. So if I put 0.1, 0.01, 0.001, what should your calculator be set to? What mode? Radians. So try it. What is sine of 0.1? By the way, be careful. This is not singed, right? Just in case some of you guys know hyperbolic functions. That's one thing we're going to learn this semester. So I don't know if any of you know hyperbolic trig functions. You all like that? Sounds fantastic. This is sine h. What do you get for sine of 0.1? 1, 1, 0, 0, 1, blah, blah, blah. What about sine of 0.01? 0.01000 stuff? Okay. What about 0.001? You see a pattern happening? So the closer h gets to 0, the closer sine h gets to h. So sine h is approximately equal to h for very small values of h. In physics, very often you'll say, okay, you got sine theta. When I swing the pendulum, I'm going to swing it very little, so I have tiny angles, so this is approximately equal to the angle. And then your work is a lot easier to do. If any of you have to take physics, eventually you're going to get to the pendulums, and that's going to happen. Right? This is a really cool outcome. If you graph this, it's going to look like this, close to 0, and that's going to be, there's going to be an open circle at 1. So this limit is 1. So what do I get? Times, right? Yeah, so I just get cosine x. Now real quick, why does that make sense? One thing we're going to focus on next time is graphing the slope of a function given the function. And this is not the easiest thing to do when you first try to do it. But now watch, here's sine. Let's just do a little bit of sine here. Right? Where's the slope 0? Where's the slope of sine 0? What would a slope of 0 mean? What kind of line has a 0 slope? Horizontal. So where would the tangent line be horizontal for this thing? Here, right? And what is that? Pi over 2. I like it. And here, it's 0, right? So in black, I'm drawing the slope. The value of the slope is 0 there and there, right? Now, we could get very technical about this middle one, but you see how it's positive? And to be honest, when we get there, we just did it basically with sine h over h. We figured out that the slope there is 1. Now, what is this the graph of already? What is that the graph of? Isn't the slope negative here? Negative? That's freaking cosine. So, of course, it makes sense. If you look at sine and you look at what its slope is doing, it's doing the values of cosine. So the values of cosine tell you the slope of the sine function at that point. So what's the slope of sine at pi over 3? What's the slope of sine? Cosine. So the slope of sine at pi over 3 is cosine pi over 3. And what's cosine pi over 3? 1/2. 11. So at pi over 3, the slope of sine is 1/2. Guys like that? All right. Some of you guys. That is getting into 2.7 a little bit. So next time we're going to fully get into 2.7, talk about 2.8. And then I'm going to have the practice test ready because the test will be a week after that. So the 4th is when we meet next. Take Monday off of all your classes because it's a holiday. Then the 6th is going to be review day for the test, and the test is on the 11th. Remember? So on next time I see you, I'm going to have a practice test to give you, and then I'll give you the answer key the next time. Okay. I'll have the quizzes graded, so you can do that. Somebody here that needed to talk to me about? Who else? Anybody else here that needs to still enroll? Oh, if you round this, like this will be 1, 2, 3, 4 places back. So it's like 0.0009999, which rounds to 0.001.
Okay.
Yeah.
So it's like 101 or something.
Oh, I see. So I wasn't really putting it in the calculator. Let's see. Is this? She had it. Yeah, this is still going to round to 0.001. Same thing. Okay, I should have done it in my own calculator. That rounds to the cell. So, yeah.
Excuse me, sir, you mean the next Thursday we don't have the test, right?
On the 11th is the test. Yes.
Okay, thank you.
You want? Oh, sweet.
Is the TA 86 fine?
Let me think. I can't remember.
I have one. I don't have batteries for it
I
though.
always forget which ones are the ones that do too much for you.
It's not in the list of things that do.
No, so yeah, the 89 is the one. The 86 is just the funky one that has a lot of stuff, but it doesn't do symbolic math. Meaning you can't put x squared minus 9 in there and it actually gives you x plus 3x minus 3.
Oh.
So it's
yeah.
fine. You can use the 86.
Okay.
Yeah.